Hello everyone. I just want to thank you for inviting me here and to talk about the test that I just started. I'm Claudia Lansac, and I want you to think about a very different place. It's also a tropical place, but it's in the neotropics in the country of Colombia. So I want you to think about the change. I'm going to talk about the study that we are currently doing there with my two advisors and also my colleague Marta. I hope you enjoy it. It all started with the study that one of my co-advisors, Patricia Burrows, made in this reserve, Laguna, which is a reserve that is in the south of Colombia. So thanks to that she spent 3 months there monitoring the amphibian community, we could make this study. Thank you to that she returned in 2019 to see how the population was. So thanks to the opportunity to return there, because she made her master thesis 35 years ago. So she could be able to return and to make this possible. So, we all know that we are on a climate change scenario. So, climate change and emerging infectious diseases which are affecting us, like for example to us, like COVID-19, and also to amphibians, and other diseases, are the most important anthropocene stressors that are affecting these vertebrates that are ectotherm. So we know that the Andean region, that is with a high amphibian diversity, is expected to experience some of the most drastic change as temperatures are rising and precipitation patterns are changing and places are getting more drier. So this will likely affect amphibians as they highly depend on humid environments and water bodies availability. So I'm sure that you all have heard about chytridiomycosis, which is a disease that is caused by the fungus of Pathrochidum dendrobatidis, but I'm sure that no one can say this name, so right now, for the rest of the presentation, I'm going to call it BD. This is the chytrid fungus that is causing this disease and is causing the devastating decline of amphibians that is well known. It was discovered in 1999. It has been detected in all continents except Antarctica, and it affects many different types of taxa. And right now we know that it has caused the decline of at least 500 species of amphibians, from which 90 are presumed extinct. For the species that we know trend populations, only 20% of them have shown recovery, and it is known that BD right now is the invasive species that has caused the most detrimental effect to biodiversity, for what we know nowadays. So BD has two stages. It has flagellate motile aquatic zoospores that attaches to the keratinizated epithelial cells of the skin of the amphibians. So these zoospores form a germ tube. Then it develops as a zoosporangium. Then the zoospores inside that sporangium divide, and then the zoospores are released to the environment to infect other amphibians. So some of the symptoms that these diseases can cause, it thickens the skin of the amphibians, and then, so you know that the skin of amphibians is really important because they permit them to breathe and to interchange the electrolytes. So it causes electrolyte imbalances, skin locking, also lethargia, and it can cause the loss of muscle control. And finally, in some species, it can cause a heart failure. But however, there are differences between species about the susceptibility to this disease. So it can affect differently depending on the species. So, well, we know that it has been identified that there are 6 genetic lineages of BD, but this study states that the origin, the BD strain, the origin of BD is from East Asia. So that's why the species there have co-evolved with this strain of BD. So that's why, as Marta said, the species in Asia are not so affected by BD as in other places of the neotropics. But what I want to point out is that the most virulent and that has spread more genotype of BD is BDGPL. We are sure that it has spread, but mostly because of amphibian trade, international. So we also know that BD has more impact in species that are bigger and have limited distributions, and in wet climates, also especially in wet climates of South America and Mesoamerica. However, the sad thing is that only a few studies of entire amphibian communities have data, but qualitative and quantitative data, pre and post BD discovery, which was in the 80s and 90s, to compare. So we are lucky because we have data of the past, like 35 years ago, thanks to Patricia, because she, in her master's thesis, as I said, she spent 3 months there monitoring the amphibian community, and she registered 39 species of amphibians and 15 species of reptiles. In 1986. So thanks to this, we have previous data to compare with the present. She even described 12 species to species new for science. So the study site was Selva Natural La Planada, where she did the study. It is a mountain called forest. It's in the Pacific Versant of Los Andes in the south of Colombia. And right now it's run by an indigenous community, the Awa village. So it was really cool. So that's the thing that I want to point out, that we could return to La Planada to see how the amphibian community has changed after 35 years later, and to assess the climate change and the impact in this community thanks to that previous studies. We could return there in 2021, so the last year. So my main objective of the study is to exactly replicate Patricia's purpose study, extending the monitoring in another periods, also to evaluate climate seasonality and microhabitat environmental conditions, and to see if BD is dependent on the species, habitats, and reproductive modes, and also to examine the skin microbiome to see if it has some implication on BD susceptibility, and also to determine some taxonomic issues of the species. So we went to La Planada about 3 different time periods. We were there on 2021, as I said, in the first period from April to July to replicate Boris study. Then we went to another wet season where the precipitation is higher. And then this year we went there in the dry season from August to September. We made sample for transit, for fixed transit in La Planada. Two of them were off the stream, fast flowing and slow flowing. Then another one for forest edge, that is an habitat that is a little bit disturbed, and the forest. And they were divided every 10 meters. Also, we made some sampling in another place within La Planada in another pass. And in another site locations outside the reserve of La Planada to consider lower elevations and see if there's some variability. Well, about the supplemental, we'll make diurnal and nocturnal visual and also auditative encounter surveys to record the frogs. And for each frog, we record their snout and length, says an age when possible, height above the ground, in which substrate they were, like leaves, rocks, or the floor, date and hour of encounter, and make some observation of the activity and photographs. Also, we record, we use a digital recorder and audio modes puts in the different transects in the field to record the localizations of the species, and also we take some tissue samples for species identification and note some reproduction and ecological observations. To assess climate seasonality and microhabitat environment conditions, we use macro and microhabitat data loggers of MARTA located in the field in the transect to assess temperature, relative humidity, and cumulative precipitation, and to assess the potential climate change in this community. For the 3D sampling, we take the skin swab of the ventral amphibians in the field, and also we take some samples in the preserved specimens in the museum, in the collection of two universities, the Catholic University, and also in another university in Pasto, Colombia. And for digit diagnosis, we made quantitative PCRs in the laboratory of the Museo Nacional de Ciencias Naturales in Spain to assess BD occurrence, BD prevalence, and BD infection intensity. So what is this? BD prevalence, we consider BD prevalence as the number of infected individuals from the total of individuals sample. But the BD infection intensity, if we only taking the infected individuals, BD infection would be the number of ITS1 copies of BD per individual. That would say the level of infection intensity of BD. So that we can have three categories of infection: low, moderate, and higher high infection level. So well, what about the results? What we could figure out in what has happened in La Planada. So if you see that few studies that I told you that have previous data, in another parts of the neotropic, you see that in the light blue, you see that this is before that bars represent the time before BD, and the dark blue represent the times after BD. And if you see, there has been a decline of the species in 3 of the places, Panama, Peru, and Guatemala. So we look at this pattern and think about what has happened in La Planada. It has been the same. What do you think? Do you think that in a place that is in the neotropics and they are also cloud forest, do you think that the decline has happened, or what has happened in La Planada? So we wanted to ask this. And to answer this. So sadly, I have to tell you that in La Planada there has been a catastrophic loss of this 4% of the amphibian diversity. As you see, from the 39 species that Burroughs saw in that moment in 1986, only 14 of them have seen in this present study. So this was so devastating that even 3 of the families are disappeared. One of them is bufonidae. There are no more bufonidae. We had in the past Atelopus lynchi, for example, and no one has seen it right now. Also, Dendrobatis family also is gone. For Dendrobatis andinus of the species that was described there, and there is no more. Also, in practice, there is an awesome species, and there's no more. We couldn't find it. And also, other families like Dragospatidae and the Drolemidae are also, have suffered severe declines also. Also, the habitat, both habitats, the stream and forest, are less diverse now than before. They have lost a percentage of species. In the case of forest, 63, and in the streams, 50. Also, not only about the number, our richness numbers, also the amphibian composition has changed. For example, this is from the most, are the 50 most abundant species in 1986, and sadly, 9 of them were found, and the rest of them, the 5% of them, is still some kind of abundant in the reserve. Well, not also richness, also they are less abundant in general. There's a lower frequency. You can see in green, you can see the study in 1986, sorry, it's wrong. And in golden, you can see the present study, and you can see the number of individuals observed, and you can see that the trend is going down. So, for example, Christimantis apiculatus and Christimantis acusatus are species that are less common now. And I'm going to talk a little bit about them because, I know that you have very different species here. For example, this is a species that is in Laguna and is from the family Dragospatidae, and it's the genus Christimantis has 20 frogs. They are direct developers, and they usually live in cloud forest. And these species have very distinct morphotypes, which mean that they have different colorations, so they are very difficult to identify in the field, and it needs taxonomic reviews. Also, it is found in the forest and forest edge. They prefer to be in the low vegetation, and the calf, we are pretending to describe the calf, because we know it, but it's not described yet. Also, this is another species of Christimantis. It's also tiny. It has very different morphotypes, as you see in the pictures. They are also active during the day. They can call during the day, because most of them are nocturnal, as you know, and they prefer to be in the forest floor. Also, we have this. It's more easy to identify in the field. It's really, I think that it's really pretty, and it's with that dark eyes. It is present also in lower elevation, and it is only found in the habitat that is a little bit disturbed, and the calf also is not bright. These are two samples of the species that remain abundant in La Granada, as you can see in the graph. This is Ilotriptis palicolilas. This is an eyelid frog. It's bigger than the tiny frogs of Christimantis. It prefers to be in fast flowing streams where males call from the low vegetation. And we found in this study that we found tadpoles and metamorphs through all the year, but we couldn't find the eggs. This is Tentarella verstica. This is one of my favorites, and this is a fast flowing stream species. Adults lay their eggs on the low mid-hanging vegetation, and males calls from that vegetation, and it has a parental care. It means that the males guard the eggs and guard the clutches. So as you can see in the picture, they are very tiny, but they are eggs. And surprisingly, there are species that now are more common than before, and maybe they have taken some kind of advantages because of the expiration of the others. Are these three species that I'm going to talk about now. This is Christimantis achatinus. This is a species that is really widely distributed in South America. It's very common in the places that are disturbed. It's really common. They usually are in the forest floor on the litter fall, and males also call during the day, like 4 or 5 p.m. With rainfall, and it's very extreme. You can distinguish it easy. This is Priscimatus laticlavius. This is the most abundant species in this reserve. It has very different morphotypes also, and we think that it needs also taxonomic revision. It's abundant in all of the 3 kind of habitats. But it's interesting that juveniles are mostly in forests, and the adults are mostly in the vegetation on the streams. And we have really interesting questions about this species because we don't know if they actually call because we couldn't hear them, and it's really abundant, and we don't know how they communicate. It's really interesting. This is the last one, Priscimatus verecundus. This is also a tiny frog, direct developer. They have also very different morphotypes, and well, it prefers to be in the mosses. The males call from the mosses where they are hiding, and they have also several types of calls, so it has a lot of work to do there. So another question was like, what has happened with this community? What are the what factors have caused these amphibian declines? One of our questions was like, it could be habitat alteration. Well, because in 1986 there was pasture actually in the reserve. But we can say that along these 35 years there has not been such an alteration of the habitat. It has been preserved, so we don't think about this. This is the reason. So about the climate, what has happened with the climate? Well, here I want to show you that, well, you have here, we have the monthly mean temperature of 6 previous years of the Patricia's fieldwork. And then in this graph, we have another 6 previous years, but previous to our study of the 2021. And you can see exactly, that the temperature has increased by 1 grade, that it seems not so much, but for ectotherms it can imply a lot, as they cannot regulate their temperature, and yes, they can be very affected. And also about the precipitation, we have the cumulative precipitation from the same years, and it's the same operation. But as you see, right now the rainfall has increased about 30%. In La Planada nowadays is more dry, and also the precipitation patterns has changed. And as you see, from January and May there was a very humid period, and right now from January to April there has been a change. It's more dry, and also the driest period right now is more long. So what we have here is that PD has arrived to La Planada. It's in La Planada. So that's one of the things that we wanted to study, but we are sure about it. So about the PD prevalence, considering the swab samples of the individuals in the field taken in 2021, we observed a 44% of total prevalence, which means a high prevalence in this community. And this makes sense because in this reserve, in this salt forest, there are ideal BD growth conditions like high humidity, and the temperature is perfect for BD because it ranges from 15 to 20 grades, which is the. And about the PD prevalence per species, well, we have some species that have high prevalence, like, for example, Spadaranus obleton, Priscimatus laticlavius, Echepilus, and Pilospithus alidolidas, and they are more infected than other species, so there are differences in prevalence. But, however, in habitats we couldn't find difference in prevalence, so the pattern is really similar about the prevalence. Well, in this graph you can see BD prevalence. That it means that we have all the species of the main species of La Planada, and here we have the BD prevalence, which means that the gray color is the species that are not individuals that are not infected. Yellow is low infected, pretty low infected individuals, moderate, and the darker one is the highest BD prevalence. And after making some statistical analysis, we obtained that Icosalidorillas, this species has higher prevalence and higher. The individuals are more infected than another species that are also abundant but are less infected, like this, and also, if we consider the months of sampling in La Planada, we can see that on May there has been high levels of infection of BD, and this is a month that it rains a lot. But well, this all can indicate that BD behaves like an enzootic disease in La Planada, which means that in this reserve there are high prevalence levels. But they are low. I mean, the prevalence is really high, but the level of infections are low. So BD is widespread in the individuals, but they are not dying. It's like they could tolerate BD at some extent. Also, we couldn't find differences in level of infection between habitats, which also indicates that BD is an enzootic disease in this reserve, as I said. So, but when do we arrive to La Planada? It's hard to say because, well, here we have the samples of the reserve specimens. This is the sample size, the number of species sample, and these are the dates in which the dates of collection of those individuals. That they are all from La Planada, and we can see that BD. This graphic only says to us that BD was before 1984 in La Planada. But we cannot. The thing is that we don't have so much sample size between these years, in between the 80s and 2006, because of the guerrilla there. So nobody could collect actually specimens there. But we are sure that BD was before that date in La Planada. So, but the thing is that we don't know which strain of BD yet. So the main conclusions of this study is that actually the amphibian community of La Planada has dramatically changed in terms of species richness, abundance, amphibians composition. Also, the climate has also varied from 1986, but we need to perform more analysis to see the effects on amphibians. Also, this is very interesting because we found that some species have appeared at La Planada, higher elevations, and this could be probably because of climate change, because they are typical of lower elevations, and also, well, we know that BD was present in La Planada before 84. So, but we have to search for. Well, we have to figure out which BD strain is there. But we think that it's the most virulent strain that I talked before, that is in the UPL, because it's the one that is more spread and also in South America. And finally, we know that BD. Well, we suggest that BD behaves as an enzootic infectious disease in this reserve. And amphibians and species there have some mechanisms for surviving there and to tolerate BD at some extent. Well, some of the further research that we want to do is to determine which strain of BD is there, to study the skin microbiome to see if it has some associations with the susceptibility in different species, to review the taxonomic issues that are, because there are a lot of taxonomic issues in La Planada, comparing morphological data, ecological linguistics, and to compare the BD dynamics of La Planada and its association decline with other studies, with other study sites in which they have also this decline. And that's all. Thank you all for hearing me. And well, I just want to thank to my mentors, to my colleague Marta, and all the support group, and our community that really helped me in the field there. And but to thank you all for hearing me.
That's all.